Have you ever blown up a vehicle's engine? Well, I have. My friend Peyton and I were on our way to Bowling Green when we noticed a ton of steam rising from the hood of my Jeep. We pulled over to find out that the radiator and the water reservoir were completely empty. My engine had overheated. Later, when swapping engines in my Jeep, I discovered the root of the problem. The previous owner had the spark plugs wired incorrectly, causing the pistons to fire out of time, which ultimately led to the overheating of my Jeep engine. My name is Micah and I attend Logan County High School. Today I will be speaking to you about how internal combustion engines function and the differences and similarities between diesel and gasoline engines. Although very different, the two engines serve many common day-to-day uses. There are two different types of internal combustion engines. There are the diesel engines and the gasoline engines. Both internal combustion engines are designed to convert the chemical potential energy in the fuel into mechanical energy. The mechanical energy moves the pistons up and down, known as linear motion, which creates the rotary movement needed to spin the wheels. Both diesel and gasoline engines convert fuel to energy through a series of small explosions inside the cylinders, which is why they're called internal combustion engines. Both have electric starters, which require a battery. Batteries need charging systems, which include alternators and voltage regulators to maintain the battery, according to A Short Course on Charging Systems by Charles O. Frio, found at www.carparts.com. Both engines require all components to be in time with each other. The cylinders, pistons, cranks, and cams all have to work in time with each other for the internal combustion engine to function properly. Additionally, both diesel and gasoline engines use cooling systems to keep the engine from overheating, like mine did. Radiators, water pumps, reservoirs, and thermostats all serve as cooling systems for the internal combustion engines. Lastly, both diesel and gas engines are four-stroke engines. The first stroke is the intake stroke. The intake stroke opens the valve, letting in air and moving the piston down. Next is the compression stroke, when the piston moves back up and compresses the air. Then comes the combustion stroke. The combustion stroke is when the piston reaches the top, fuel is injected at just the right moment and ignited, forcing the piston back down. The fourth stroke is the exhaust stroke, where the piston moves back up to the top, pushing the exhaust created from the combustion out of the exhaust valve. As you can see, these engines have many similarities. Now for the differences. Unlike gasoline engines, diesel fuel is combusted by compression alone. This means diesel engines do not have a distributor and do not have spark plugs. Nor do diesel engines have a carburetor. Only direct fuel injection by EFI, or electronic fuel injection, according to How Diesel Engines Work by Marshall Brain, found at www.auto.howstuffworks.com. Diesel engines have lower RPM torque, redlining as low as 3,500 RPMs. There are often two batteries in diesel engines since the low RPM torque takes more to turn over the engine. Diesel engines are notorious for their longevity over gasoline engines. Because diesel is more lubricating than gas, it causes less wear and tear on engines. Diesel engines often have an added turbo, which increases performance and efficiency, but increases exhaust temperatures. A disadvantage of diesel is that it will gel up in sub-freezing temperatures. Diesel fuel should always be treated beforehand with a diesel treatment anti-gel. If by chance you forget to treat before gelling, you should buy a 911 treatment to liquefy the gelling. Diesels have glow plugs to warm up the cylinders and fuel for cold weather starting. Diesels may also have a block heater, which can be plugged up to an alternating current outlet so the glow plugs don't have to work as hard. In gasoline engines, fuel is combusted by an ignition system, which includes a distributor and spark plugs. The spark plugs have to be wired in such a fashion that they will ignite the cylinders in an order that allows for cooling in between firing. This is called the firing pattern. Failing to wire the spark plugs according to the manufacturer's firing pattern may result in the overheating of an engine, just as my Jeep engine overheated. The gas engines use fuel and air mixture. Fuel and air can either be mixed together by carburetor or EFI, again, electronic fuel injection. Carburetors mix fuel and air mechanically by a floating device to ensure the correct ratio, while EFI is all computer regulated, using data from O2 sensors to know how much gasoline to inject. Gasoline engines have higher RPM, which stands for revolutions per minute, by the way, torque, than diesel engines, redlining around 6,000 or 7,000 RPMs. Also, gas engines typically only have one battery. Very seldom are there two, in which case the second is usually used for auxiliary lights and equipment such as pulling trailers. Gasoline is a less lubricating fuel than diesel, which is harder on the engine, causing gas engines to typically wear out more quickly than the diesel engine. Some gasoline engines will have a turbo, but it's more for speed and sports than it is for day-to-day travel, according to How Does a Turbo Work? By Jordan Perch at shop.advancedautoparts.com. Lastly, gas engines are more resistant to cold temperatures because gasoline does not gel like the diesel fuel does. Internal combustion engines all run similarly, but they have their significant differences. There are many components that must work together for engines to run smoothly and not overheat, like mine did. They both convert potential energy into mechanical energy, but achieve this differently. Both engines get the job done in their own way.